Kingsport, can you all see and hear us okay?
Yes, we can hear you, and we can see you.
All right, that's a good thing.
I know. Can you hear and see us? Well, see Mike's desk anyway.
Yeah, I see you, or I see Mike's desk fine, and I hear you good.
Okay, that's great. We had a miss earlier.
That's what I heard. I heard it was like a war room.
It was. I feel so inadequate.
Oh, that's not your fault. Every now and again, that room needs to be reset, I think, and it's probably been a while since it's been done. So
I'm sure it has.
Here for the rest of the semester.
Yeah, I hope it will.
Oh, everything's
Everything looking good on this end, Mike. It's shared perfectly.
Hey, let me ask you a question. Do you see like a green background on my board?
I'll fix it. I'll fix it.
I do. It's the like
We got a loose connection.
I'll fix it.
We're going to be purple here or something.
You
Debbie's
do
going
know how to do that.
to fix it for us. Ah, you're the best.
internet students, can you hear me now with the microphone on? Let's do a test to you all real fast. You can just type to me. You don't have to unmute your mics if you want. All right. Thank you, Abigail. I'm going to mute the mics again, and he'll start back up at 5:30, pretty much on the dot.
Always on the dot.
Hey, Mike, will you need the attendance tonight, or will that become next week when you got to turn that in?
Today's the 24th.
Yeah.
No, I'll ask you for it next Tuesday because I'll have to pick up some stuff from the daytime class with Dia. Well, I'm going to pick up a bunch of stuff on Wednesday, so I'll ask you on Tuesday.
Okay, I'll have it ready for you.
Yeah, I got to do it next week sometime.
Good, because I'm a little bit behind on one of the classes, so I'm all caught up now. Paperwork-wise, I just got to get the Excel caught up, so I'll be ready.
Yeah. I'll ask you on Tuesday for it. So the first thing tonight is I'd like to get our first homework assignment, and it's going to be for Tuesday, that's the 29th. So what I've done is I went through and picked some problems out of chapter 1, just to get us started here. And so I picked problem 1.3, and the reason I'm writing bar graph here is because it asks you for a bar graph, and I'm going to want that bar graph out of Minitab, right? We don't do anything by hand here. And then, now, realize that 1.3 is on page 20, so it's like in the middle of the chapter, right? So it's not at the end. Okay? And then I went to the multiple choice ones. Now those are at the end, and I underline them because they're multiple choice. And then so all I need out of these problems are the answers, right? So you're going to got 3 choices, I believe, with those multiple choices. You're going to give me like the A, B, or C. And I picked these. Still multiple choice. Okay? And then after the multiple choice ones, I think they're called check your skills or something, and then there's like problems after that. And I picked 3 problems, 130, 131. Now, the graphs you need for these are in your textbook, so you don't have to produce them. I think one has a histogram and the other one has a stem plot. So you just answer the questions looking at that stem plot or that histogram. And then 134, they give you the data in the file, and you actually have to make the histogram. Right, so everybody understand that 1.3, make the bar graph and mini-tab, print it out. Look, I'm going to give you some options here. If you want to do the homework problems in Word, that's fine, and you can just insert the bar graph and the histogram in those problems. If you want to do it by hand, that's fine, right? If you want to write everything out for me, that's fine. Print the graphs out and stick it with your homework. You folks here with me, you're going to bring it to class on Tuesday, put your name on it, I'll pick it up. You folks with Rob in Johnson City, you're going to bring it to Rob, and he's going to pick it up, and then I eventually get it on Wednesday. You folks that are streaming, what's going to happen is, if you do everything in the Word document, put your graphs in the Word document, then you can just send me the Word document. If you don't want to do it like that, you want to work by hand, then you can take pictures of your homework. I still need these graphs out of Minitab. What I ask for the people that are streaming is when you send me that file as an attachment to an email, I would appreciate that if you, in the name of the file, you would put your name in there. It saves me a step or two. Okay, the rest of you folks are going to bring it to class. Everybody clear here? All right? Now, here's a little thought. You remember these files, right? These are Minitab files. So the one you need for problem 1.3, in your book at the end of that question, there's like a little thing that looks like some kind of little data thing, and it says social media. And if you come over here and look, it's EX, right? So EX are the exercises. Remember, I warned you the EGs are your examples, yes? The names always match, right? So for 1.3, you need this EX0103 social media, and for 134, you need EX01-34 food oils. Those are the files you need to have when you have Minitab up and running, upload and put in there, right? Open that way. One more time. What's wrong? We're okay?
Yeah.
You had that look like I had said something bad.
I do. I need a pen or something. I've got everything in here, but it's in my...
Okay, so I've got Minitab. Remember, and I told you this is Minitab up and running, right? So if I want to load the file that I need for the bar graph 1.3, so you know, I got them downloaded to my desktop, so I got to go and I double click my desktop, and then I got to find users, my username, there's my desktop, there's the Minitab folder, I keep clicking, there's chapter 1. Notice that's exactly what I just showed you outside of there. I didn't click on any of those files when I had them up before because the computer would have laughed at me, right? I have to have Minitab up and running and open it through Minitab. And then I'm looking for this one about social media. And I'm going to click OK here once it tells me that. Look, that's nothing more than the data that's in 1.3 here in a nice table. Now, something I want to show you. I'm going to read this question to us. I want us to get started right on the first homework set, okay? It says that 1.3, which is on page 20, social media preferences for younger audiences. Facebook remains the top choice of social media over all ages, with 65% using Facebook, most often among those using social media sites. However, more visually oriented social networks such as Snapchat and Instagram continue to draw in younger audiences. When asked, which one social networking site or service do you use most often, here are the top sites chosen by Americans aged 12 to 24 who currently use social networking sites or services. So what they could choose is Facebook, Instagram, Snapchat, Twitter, Google+, Pinterest. All right? Okay? And what I see is, I'm going to show it to you here, because it's the same thing that's in the book. Facebook's got 43%, Instagram's got 18%, Snapchat 15%, and so on and so forth. All right? It says, the problem says, what is the sum of the percentages for these top social media sites? What do they want me to do? They want me to add 43 and 18 and 15 and 8 and 4 and 3. I need help. I'm guessing it's 91. That was me closing my eyes and seeing the numbers on the board. So 61, 76, 84, 88, 91. Right? So I just added those up. That's what's asking. Okay, what percentage is in those categories there? It'd be 91. Everybody okay with that, right? So that's your first answer is 91. It says, what percent of Americans aged 12 to 24 use other social media sites most often? How do you find the other? How do you find the percentage that chose something other than the 6 that are listed there? They only get to choose one, right? So if 91% chose these 6, what percentage chose something other? That would be 9%, yes? So that's the second part of A. It says, make a bar graph to display these data. It's definitely a categorical variable, right? In other words, what social media site do you use? It says, be sure to include an other social media category site. So how do I do that in my bar graph? Everybody pay attention. I can actually come here and I can type in my little spreadsheet. I'm going to put other. And whatever you figure out the other was, everybody else was? Okay? I want to remind you how you make your bar graph. Graph, bar chart. I'm going to bake you at this point in this drop-down menu is you have values from a table, right? You're looking at a table in the data here at the bottom. So we choose values from a table. We just want a simple one, and we click OK. It says, where's the graph variable? In other words, where's that percentage or count? It's in the share. I need a category variable. Where are the different social media sites? Format. There's your guy. Right? That's the one you need for the homework. Now remember we had this little talk about if you're a Mac user, it's 2 fingers and you can copy the graph and paste it right in a Word document. If you are a PC user, I can be nice here and send the graph directly to Microsoft Word, or if you copy the graph here and you go to paste it in Microsoft Word, remember in the upper left-hand corner of Microsoft Word there's a paste. You have to choose Paste Special, Device Independent Bitmap, and then tell it to put it in there. If not, you don't get the labels, right? Okay? It's the first homework, so I'm going to be kind of nice about it. I'll remind you this next Thursday or the next Tuesday when I give it back if people forget. All right? Now, here's my other warning about the homework questions. Now you notice I read every questionnaire and it says, okay, part C says, would it be correct to display these data in a pie chart? Why or why not? Would it be correct? It would only be correct if you had the other category in there, right? Because then you would have 100%. The way it's given to me without the other, the answer is no. So your answer can be yes if you put in the others. It's no if you don't. Okay? And then I don't have anything really to say about the multiple choice questions, really. All right? But what I do have, you're just going to read them and answer them, 114 and the ones I gave you there. But if we take a look at 130, I just want to get you so you answer all the questions that are there, if you don't mind. All right? So I'm over here on page 39, 130, right? Do adolescent girls eat fruit? We all know that fruit is good for us. Many of us don't eat enough. Figure 1.14, which is underneath the problem here, is a histogram of the number of servings of fruit per day claimed by 74 17-year-old girls in a study in Pennsylvania. All right. Now, they didn't give me the data, so you're not going to see me pop it up here. It's in your textbook. And it says, describe the shape, the center, the variability of the spread, right, by giving me the smallest and the largest. Are there any outliers in the data? There's 4 things there. And they're not labeled A, B, C, and D. It's, okay, give me shape, center, variability, spread. Give me any outliers. And then it says, what percent of these girls are ate 6 or more servings per day? If you're looking at your textbook, what does 6 or more mean? They ate 6, 7, or 8. Yep. So how many does it look like ate 6? Just a rough estimate. Everybody call that maybe 3? Right? The height's about 3 there. Yep. What about 7? About 3? 8? About 3? So about 9 of these ate 6 or more servings of fruit, right? It doesn't ask you for how many, it asks you for the percent. How are you going to calculate the percent? How many are in this histogram total? How many 17-year-old girls did we ask this question to? 74. So if you'll take 9 and divide by 74, that will give you the percent that ate 6 or more. One more question here, and I know I'm giving you a really good head start on your homework problems. Yep. It says, how many of these girls ate fewer than 2 servings per day? What's fewer than 2 mean? None, 0, or 1. How many does it look like ate 0? That looks like 15 to me, yes? How many does it look like ate 1? That looks like around 11. So that's 26. It doesn't ask you for the percent. Here it's asking you how many. So it looks like 26 of these 17-year-olds ate fewer than 2 servings of fruit. We okay? Okay. And then I come down here to 131. IQ test scores. Figure 115, which is a stem plot underneath the problem of IQ test scores for 78 7th grade students in a rural Midwestern town. A. 4 students had low scores that might be considered outliers. Ignoring these, in other words, cover this shit up. Now tell me about the shape, the center, and the variability of the spread. Right? So remember, when you're looking at a stem plot like this, if you want to talk about shape, you rotate it, right? And then you tell me what you see. Then it says, we often read, part B, we often read that IQ scores for large populations are centered at 100. All right. What percent of these students have scores above 100? What's above 100 mean? What I want to know is 100 above 100? No, 100's 100. Above 100's above 100, right? You don't count the ones that have 100. Now, when you look at this stem plot, what you're going to see is that the stems are in the tens position, and the leaves are in the ones position. So when I look at this, somebody had an IQ of 72, 74, 77, 79. Somebody's got an IQ of 136, right? So the leaves are in the ones position, and the problem actually split the stems for us there. Again, I don't have to make the stem plot. It's there looking at me. 134, the one I told you need to make the histogram for. Page 40. Food oils and health. Fatty acids, despite their unpleasant name, are necessary for human health. 2 types of essential fatty acids called omega-3 and omega-6 are not produced by our bodies, and so we must obtain them from our food. Food oils, widely used in food processing and cooking, are a major source of these compounds. There is some evidence that a healthy diet should have more omega-3 than than omega-6. Table 1.4, which is on the bottom of page 40, gives the ratio of omega-3 to omega-1 in some food oils, right? So I don't know how many is there. This looks like there's 20-some, maybe 30, right? It doesn't tell you how much is in it. It tells you the ratio of them, the omega-3 to the omega-6. And what it says is, values greater than 1 show that an oil has more omega-3 than omega-6. Values less than 1 means that it has more omega-6 than it has omega-3. Values that would be exactly 1 means that it has the same amounts of both, right? So what they did was, they took how much it had omega-3 and they divided by how much they had omega-6. All right? It says, make a histogram using class bounded by the whole numbers from 0 to 6. I want to show you that again. I know. If you don't like me helping you with the first homework, just close your ears. Okay? So that's that same table that's in the book, and there was actually 30 of them there, right? Now I want to make a histogram. Stat, histogram. I never mess with anything here. I want a simple one. What do I want? Where's the variable? It's the ratio, right? Of omega-3 to omega-6. Now, I don't know what minicab is going to choose for the classes, but they're telling me what to choose for the classes. So what's the first thing me and you always do? We come here and we go to binning and we choose cut point. Remember, so that we're marking at the edges of the bars. And again, I don't know what minicab is going to do, so I'm going to say okay to see what it says, what it shows me. Again, it's not the whole numbers, right? It's going from 0 to 0.6, 1.2, 1.8, 2.4. It tells me to go 0, 1, 2, 3, 4, 5, 6, right? We're going to do that. Remember, we double click. Binning. I don't have to change the cut point. I have to change their positions. I want to go 0, 1, 2, 3, 4, 5, 6, right? That's what the problem's telling me to do. I give you a little bit of practice messing with this. I click OK. Folks, that's the histogram you want for this problem. And then while I got it up here, what's it asking me? It says, what's the shape? What do you think? Oh, dear God, it's real life data. Nothing's as perfect as I draw. I'm sorry. It's looking to me like things look like they're skewed to the right here, maybe with a possible outlier, right? Yeah, definitely got a tail going out. Single peak. It's got that one big hump at the beginning, right? Between 0 and 1. You know all the ones between 0 and 1s are the ones that have more omega-6 than it has omega-3, right? It says, how many of the 30 food oils have more omega-3 than omega-6? Which ones are we looking at that have more omega-3 than omega-6? Those are the ones that have a ratio greater than 1. You're looking at right? Those are all the ones that have more omega-3 than omega-6. How many's here? Yeah, don't let me lean them on like that. That looks like 1 to me. Please? Looks like 1 to me. Looks like 1 there. I'm going to guess there's like 4. I was going to say 3, but there's 4 there. There's 1 there. There's 1 there. What'd I count? 7? There were 7 of them that had more omega-3 than omega-6, had a ratio greater than 1. What does this distribution suggest about the possible health effects of modern food oils? Oh, it suggests things aren't too good, right? Because there's 7 of them that are supposed to be healthy. How many are unhealthy? Why did I put my thing there? 23 out of the 30 are not good for you, folks. They have more omega-6 than omega-3. So what does it suggest? This is not good. Right? They're not, overall, these food oils are not healthy. Okay? It says, Table 1.4 contains entries for several fish oils, cod, herring, menhaden, salmon, sardine. How do these values support the idea that eating fish is healthy? I'm going to come right down here. Let's just find one of these. What was it? Herring, 2.67. Salmon, 2.5. Herring, salmon. I'm trying to remember what the other ones were. I don't remember the rest of them. It turns out when you look at the table, what you're going to see is all those fish food oils have a ratio greater than 1. What does that mean? Those are the ones that are supposed to be healthy for you, and they are healthy for you because the ones that have a ratio greater than 1 are the healthy ones. Are we okay? Please, when you're doing the homework, I've answered, at least for those couple problems, I answered all the little questions. Even though there's like a part A, there could be like 3 things you got to answer. There's a part, answer all. I'm a smart ass, and the way you know you're looking at a question, there's a question mark at the end of the sentence. Unless it says, describe the shape, center, variability. And then it's just going to say, just do that. All right? We'll see how the first one goes. Once we get rolling, I do this like once, like every Thursday when we don't have a test. Just so that you keep up with me here. All right? Again, That's what the graph looks like. Fix it. Does everybody understand what's going to happen? Yes? Yeah. You tell me that now. So the other thing is this. If anybody's emailed me this semester, you know I answer. And I answer rather quickly. And especially this weekend when you have the first homework is due Tuesday, I won't stray far away. Especially because I'm getting you to use Minitab through GoldLab, whatever type of computer you have. So if you email me, I will email you back. Right? I won't be far away. I will be helpful. That will be your biggest thing. Answering the questions won't be a problem because we talked about most of it, and I consider them rather straightforward. I mean, it's not like you're going to be looking at something trying to decide, is the thing roughly symmetric or skewed to the right or left? Shit, you saw that was skewed to the right. The ones in the book, I mean, it's like an obvious thing. And remember, when you're trying to pick the center off a histogram, just give me like a little range where it is, right? You don't have to give me an exact value, okay? The last thing we talked about on Tuesday was a time plot. I'm almost ready for the next chapter. And what I was thinking and what I said, but I wanted to say it again to you today. We have two different graphs here. Okay? The time plot is where you have some quantitative variable measured over some time periods, and we made the little dots and connected the little dots, right? That's what I showed you on Tuesday. So what they do is this. They talk about this as being time series data. And what we mean by that is you only have one individual. Right? It's not like you have a whole different collection of individuals in your data set. You only have one individual, but what you do is you measure the variable many times. Right? So in other words, when I say many times, is whether you're going to do it every month, every day, every year, whatever, you're going to have this one individual, and you're going to measure that variable on that one individual for these different time periods. And that's your data. Right? So time series data, one individual, measure the variable many times. A histogram, on the other hand, is called cross-sectional data. And what that means is you have many individuals, and what you do is you measure the variable one time. So cross-sectional makes sense, right? You've got all these individuals, you're picking a section of time here, and you're going to measure that variable on all those individuals at that time. I just want you to know that, you're kind of talking about the same kind of thing here, but not exactly. And my terminology here, these are just fancy statistician terms. And what I mean is, somebody talks about cross-sectional data, or somebody talks to you about time series data. I just want you to know that the time plot, you only got one individual, and you measure the variable a bunch of times, right? With a histogram, you've got many individuals, and you measure the variable only at one time. That's what I want you to know. You'll never hear me use time series data, cross-sectional data on you again. I just want you to make sure that when you're looking at the data set, you know what you should be making. Right? That's all. Okay? So if you don't mind, I think we can move to the next chapter. It's going to look a little bit like a math class tonight. Not a lot. A little. And you're thinking you guys always thought this was a math class. How many calculations me and you do in chapter 1? Well, no, the worst freaking thing we calculated was like a percent, right? Like 9 out of 74 or something. Other than that, we didn't calculate anything. So, chapter 2 is we're still working with this idea of distributions, and we're describing distributions with numbers. So this is the chapter where we actually calculate something. All right. Now, here's what I want to do for you is what we're going to calculate, and the reason I wasn't like crazy about measuring the center and the variability / the spread is because we're going to calculate that now. So here's what we're going to do. And you're going to check me when we're done with this chapter next week. What I want to be able to do is I want to calculate center, and then, like I said, I always use the term spread. I'm going to put variability there too, because that's the way your textbook talks about it. Right? Now, the deal is going to be is there's going to be two ways to measure the center, and there's going to be two ways to measure the spread. And it's going to come down to, depending on what we're looking at. And what I mean is the shape. Okay? And then the other thing I promise you is that's one. And then two, I would like a formula for suspected outliers. So what I'd like to come up with here is I'd like to come up with a way, and my hands are going to move like this because here I'm looking at my histogram, and we know at this moment outliers are ones that are out by themselves. I want to know how far away from everybody else I need to be before we start saying, okay, that's far enough. Not just looking at your histogram and saying, there's an empty class there. That still may not be far enough depending on what the rest of the data looks like. So I would like a formula for suspected outliers. Okay? So, here's where we're going to start. I'm on page 47, and it says, we saw in chapter 1, page 14, the American Community Survey asks, among much else, workers' travel times to work. That was like right at the beginning, the first night me and you talked. And it says, here are the travel times in minutes for 15 workers in North Carolina. So in other words, you've got 15 North Carolina workers. Those are your individuals. And what you measured on them is, I'm just going to write travel time. It's their travel time to work. It's got units, and the units are minutes. Everybody so far so good. And so what they do in your textbook, for you folks that don't have it, is they just got them listed. They got these 15 travel times for these 15 randomly chosen North Carolina workers. The first one, it took 30, 20, 10, 40, 25, so on and so forth. And what they're going to do for us is they're going to make a stem plot of this data. All right? And the stem plot is on page 47 also. I want to remind you something before I say anything about that stem plot is, there is somebody here that took 5 minutes to get to work. Hell of a job, nice place to live, I guess. Right? Okay? If I'm going to make a leaf and a stem here, what did we do last Tuesday to handle this? I put that little 0 out front that nobody ever writes. And I told you, there's my stem. There is my leaf. And then from that, they go ahead, and the rest of them are okay, right? They just make the first digit is the stem, and the ones position, the last digit is your leaf, and they made the stem plot for us. And when I look at that stem plot that's in your textbook, what I see is the stem plot is single peak, I'm always giving you this other term, unimodal. Unimodal means single peak, like a single big hump. And you'll notice it's in your textbook like that. I'm going to look at it like that, right? I turn it 90 degrees. It's single peaked, unimodal, same thing. And it looks to me like it is right skewed. Or if you like, skewed to the right. There's a tail going out to the right there. All right? And I'm reading that all off the stem plot. Now, I'm not going to eyeball the center and spread because we're going to calculate it in this section. And the other thing I notice is there is somebody that took 60 minutes to get to work. That 60 may be an outlier. Why do I say that? Because the next closest travel time in these 15 is 40. So this person takes 20 more minutes than everybody else that's in this STEM block, so that may be an outlier, right? It might be stuck out there in the table. So, the first thing we want to calculate here is, we want to talk about calculating the measuring the center. And the first measure of the center we talk about is something called the mean. Hell, you guys already know this. You already know the mean. Now, how do you find your average grade in the class? You already know that. It's on page 48. I want to look a little bit at the formula, and I just want to make sure you understand the notation. All right? It says, to find the mean of a set of observations, however many you have, it doesn't matter, all right? Add their values and divide by the number of observations. Well, shit, you guys do that. Add them all up and divide by the total number of observations you have, right? Yeah, in English, that's how you do that. It says that the n observations are labeled. In other words, I got to give it to you all in symbols. Now, look, don't freak out. That's just, I've got n values, right? I got n observations. Those are the n numbers. There's x's subscripted by a 1, 2, 3, up to n. It says x bar, which is, that's how we denote, that's the notation, is x bar. Anytime you see an x with a bar, they're talking about the mean. They're talking about adding them all up and divided by the total number of them. All right? In formula, it would be add them together. And divide by the total number. Everybody good with that, right? So there's like mine and yours first formula for the semester. All right? Now, shorthand. This can also be written as yeah, I know, we're not all math majors. I understand that. We're adding all the pieces of data together and we're going to divide by the total number. Does everybody see this guy right here? Yeah, that's sigma. That's the capital Greek letter sigma. When you see the capital Greek letter in sigma in a math class, it means add, sum. It's telling you, would you please add up all the observations and then multiplying by 1 over n, or if you like dividing by n, is the formula, right? Look, you know math people, we love notation. You know, if I can take something this big and write it that big, math people are happy, right? We love notation. We actually also like the Greek alphabet. Why? I don't know. We like the Greek alphabet, right? Every time I see that sigma in any of my math classes, anytime I was ever in math class, what does it mean to do? It means add. Add these guys together, right? Now, are you going to memorize this? No. Remember those formula sheets that you printed out, those 6 pages? The mean is probably on the first page there somewhere. And look, to be honest with you, after tonight, if you don't know how to calculate the mean without the formula, you mean you got a problem. Okay? Now, here's the thing about this. Before I calculate anything for you, I'm going to go through some of this, and I'm going to tell you, look, you need to be able to do this by hand. In other words, what I mean about calculating x bar by hand, you need to be able to have a calculator where if I give you maybe 10 or 12 numbers, that you could add them up and divide by 10 or 12. In other words, that's what I mean by calculating the mean by hand. Not you doing all the handwork here. I mean, put it in the calculator and calculate. All right? Okay? So, let's see if we can calculate the mean of these 15 North Carolina workers. All right? So, my thought is, example 2.1, I've got my 15 North Carolina workers. Okay? Now, I'm not going to sit here and pull a calculator out and add those 15 numbers up and divide by 15. What I'm going to tell you is your mean of those 15 workers is 22 and a half. All right? In other words, if you add those 15 numbers together and you divide by 15, you'll get 22 and a half. I trust you can do that without me punching it in a calculator. Now, here's the catch. Normally, everybody would be happy if your answer was 22 and a half, right? But you're in a statistics course and we're very verbal. There's actually units here. The mean has the exact same units as your original observations. That's not just 22 and a half. That's 22 and a half minutes. Everybody okay with that, right? Now, I need to take this one step further. And I want to back up here just 1 second. You see this guy right here? And I warned you about this on, it was either last Thursday or Tuesday. When we have an outlier in the data, we always want to make a note of that, right? Remember I told you it screws up the kind of stuff you want to do. So, I would like to calculate the mean again. But this time I'm going to do it without the 60, right? So without that 60 minutes. In other words, I've got 14 North Carolina workers. Everybody okay? In other words, do the same calculation again, just leave out the 60. You'll end up dividing by 14. And what you're going to get is, this time you're going to get X bar is 19.8 minutes. Yeah. Okay. Is that a very big difference? Okay, so then you have to have some kind of feel about numbers. So it's actually, with the possible outlier in there, it actually goes up by 2.7 minutes, right? Now, is 2.7 minutes a lot on around 20 minutes? Folks, that's a 10% change. Yeah, that's a big move, right? In other words, with the outlier in there, you got 22 and a half. With it out there, you got 19.8. In other words, the outlier makes a big change in the mean. Yes? Let me ask you this. Which way does it move the mean? In other words, here's my data. Remember, this is my number line. 60's out here, right? When 60's in there, the mean is here. When 60's out, the mean is, yeah. Put 60 back in, and it pulls the mean towards that outlier, doesn't it? So, I've given you the thought, but the fact is, about the mean is sensitive to the influence of a few extreme observations. Oh, the extreme could come from it being outliers. It could also come from being the tail of the skewness, right? Because remember, if you're skewed to the right, the tail goes out there and the mean will be pulled, right, by those ones that are in the tail, even though they're not outliers. So that's a nice way to say it. The mean is sensitive to the influence of a few extreme observations, whether those observations are outliers or whether they're from the skewness. And so how's the mean influenced? We always want to know. I always want you to know, okay, if it's influenced by these guys, how's it influenced? Well, it's pulled towards the outlier, whichever way it is. It could be on the high end or the small. It could be pulled this way if it's small. What is the tail going to do to it? It's going to pull it out the tail, right? Whichever way the tail is, it'll pull it out the tail. So the way these extreme observations influence your mean, if they're outliers, it's pulled towards the outlier. If it's their tail, it's pulled out the tail. Are we okay with that? All right? Because we got to know, I can't just leave you with shit that's influenced. How is it influenced? Okay? Now, the way a statistician would say, they'd say the mean is not a resistant measure of the center. And I'm going to underline this. when somebody tells you that the mean is not a resistant measure of the center, what they're trying to tell you is the line above is sensitive to the influence of a few extreme observations, whether it's a tail or whether it's an outlier. Right? All right. So, before I move on to my next measure of the center, when would be the best time to use the mean to calculate the center? Now, I'm basing this off of the shape and or outliers. If you are skewed, is the mean a good choice? No. If there's outliers in the data, is the mean a good choice? No. What the hell's left? Roughly symmetric? No outliers. So, tonight, I have the mean here. It's good to measure the center with the mean when you're looking at your histogram or stem plot and you see something that is roughly symmetric and no outliers. That's the mean. So what's left over in this hand? I didn't give you the calculation yet, but what's left over? Outliers and or skewness. I need something to measure that, right? Okay. Before I get to that, I want to come back here and ask you something. You see this number? Suppose that wasn't 60. Suppose it took somebody 120 minutes to get to work. What did that do to the mean? It even pulled it further, didn't it? Right? It would be 22 and a half. Hell, be bigger than that. Yep. See, with the mean, all those observations count. And what I mean is, their values are actually used in calculating the mean. How do I know that? They all get added in, right? So the actual value makes a difference. If that was 60 or 180 or 240 or 360 or 6,000 or whatever it is, the reason I'm moving this way is because the mean just keeps moving with me, right? The values actually make a difference here, okay? All right. So then we need our other one. There is another one. And the other one is measuring center. It is called the median. All right, I'm going to be honest with you. On Tuesday when I was eyeballing the center of a histogram, and I was finding half were smaller than this value and half was larger because half the area was here and half the area was here, I was finding the median. Let me ask you this. When you're driving down the interstate and you got that green shit in the middle of the road here to your left, what's that called? Let's call it the median. What's the median do with the two lanes that's on this side and the two lanes on this side? It divides it in half. What are we going to do here with the median? We're going to divide the data in half. Half is smaller, half is larger. All right? I'm going to give you the page number. All these little guys show up in a box here. Now, the first thing is the median is denoted by, that's a capital M. When you see capital M in this class, somebody's talking to you about the median, this 50-50 point. All right? Now, I'm not going to write the rest of this down. I don't know if in your textbook or whatever you do, or if you're a highlighter, if you're a marker, but I'm going to look at this and it says, the median M is the midpoint, right? It's the middle. The number says that half the observations are smaller and half the observations are larger. So I'm going to write that part, right? Half smaller than this value and half larger. Okay? 50-50 point. Midpoint. Now, there is a 1, 2, and 3 here on how to find your median. It's not like I'm going to add them up and do any calculation like that. It says, number 1, and this is the most important for you guys, because this is the one you will forget when I give you this on a test. Right? It says, arrange all the observations in order of size from smallest to largest. That's step 1, right? And so write them all down from the smallest to the largest. Sometimes they'll already be in order for you if there's a large number of them because, it takes a while to put them in order. All right? And then going from there, it says, if the number of observations odd is number 2, or if the number of observations is even still in number 2, this is how you find it. Let me ask you this. What does it mean to have an odd number of observations? What are we looking at? Does everybody know what an odd number is? 1, 3, 5, 7, 9, 11. Does everybody know what an even number is? 2, 4, 6, 8, 10. I got to ask you a question. If I've got an even number of things, let's say I only have 4, and I've got them in order, when I find the middle, am I not between two of them? When I got an odd number of things, let's say I got 5, right? And I'm going to find the middle. Is there one of them that's actually in the middle? Perfect. That's all I needed to know. Then we can go on about our business here, right? How do we calculate this? So what I want to do is I want to look at this example 2.2. Okay. I'm going to look at all 15 North Carolina workers. And I'm going to put their 15 travel times in order. They go in order like this. 5. I got to quit talking while I write these. Because you understand, if I screw this up, I screw the rest of the problem up. Remember, this is the most important thing, is putting them in order from smallest to largest. And so, and then what else I'm bad about? And you're wondering, what am I doing? I'm counting to make sure there's 15 of them. But I got them all, right? Now, the way you do this is, there's definitely an odd number here. 15 is an odd number, so you're actually going to land on one of these values. The way you do it is, the way you find the center, the middle of any number of observations is, you take the number of observations you're given, you add 1 to that, and you divide by 2. So what is 15 plus 1 divided by 2? You get... Now, 8 is not your median. 8 is where it is in your list. So you count from the beginning. You count across 8. 1, 2, 3, 4, 5, 6, 7. That's the 8th one. What I'm telling you is here is your median is 20 minutes. Did it do what we said it was supposed to do? Are half of them smaller and are half of them larger? In other words, there's 7 there, there's 7 there. You're dead in the middle. It has the same units as the original observation, so you're looking at 20 minutes. One more thing to be said. You got a whole number, obviously, because you had an odd number and you added 1 to it. You're going to get a whole number. You're going to land on one of them when it's an odd number. Okay? Everybody good with that? Now, you see that 60 that's in there? I just got to ask you this question just to get this stuck in my head at the moment. Suppose that 60 wasn't 60. Suppose it was 120. What's the median? Does it change? Suppose it was 180. Is the median still 20? See, the difference between the mean, where all the values get added in, the value actually makes a difference. With the median, does it matter if that's 60, 120, 7,000, 10 billion? The median is still 20 because it's just a placeholder. The actual value of it does not matter. Why am I bringing this up? Because when would the median be a good choice for the center? When you had outliers where you saw skewness, right? Okay. Now, I got to do another one of these. And what I'm going to do here is I'm going to go to the next example. And what we got to do is we got to change the data. And so in example 2.3, what we're going to do is we're going to change states. It says, travel times to work in New York State are on average longer than in North Carolina. Here are the travel times in minutes of 20 randomly chosen New York workers. So I got 20 New York workers. Okay? So they give me the data. You know, somebody took 10, 35, 25, 40, 20, so on and so forth. Right? I'm just reading them across there. And they make a stem plot for me. Okay? So in this case, the stem plot, again, is single peak. Unimodal. And skewed right. Or if you like right skewed, I'll take either. Okay? So, for you folks that don't have a book, what I'm looking at here is they got the stem plot there. If I turn it this way, you can see it's right skewed, right? I got any possible outliers here? Yeah, somebody took like 85 minutes. Yeah, there's a possible outlier there. Okay? Now, if me and you was going to find the median, what's our first step? You're going to put them in order, right? From smallest to largest. Here's my question. Are they in order in a stem plot? Oh. Are the stems in order going down the page? Are the leaves in order going out the page? So is the data, if I read it like this, are the data actually in order? And the answer is, yeah, there's no need to waste my time putting them in order. Hell, they're in order, right? So, I'm going to use the stem plot this time to find the median, right? Use the stem plot. To find M. There's no need for me to waste my time writing down them in order. They're already in order, so I may be a stem plot. Now, how many pieces of data do I have? 20. How did I tell you to do that? Take the number of observations, add 1, divide by 2. Everybody okay? Right? Don't be shocked. You're going to get 21 divided by 2, and it's going to give you 10.5. Now, what does the 0.5 mean? You're going to fall between two of them, right? Because there's not a 10.5 one in the position. There's the 10th one and there is the 11th one. So, what I know is I need the 10th and I need the 11th. And what I mean is I need the 10th value in order and I need the 11th value in order. So how am I going to do this in a stem plot? I'm going to sit here and I'm going to count, right? I'm going to count the first, 5, and I'm going to count the 0, 0. I'm going to count out one stem, then I'm going to come right to the next one and start over again. So when I do that, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th one has a value of what? The leaves are the 1's position, the stems are the 10th position. This one has a value of 20. The reason you didn't see my finger move off the page here, because I need the next one. I need the 11th one, which has a value of 25. Now, here's our deal. The median, as far as anybody cares, we can pick any number between 20 and 25, and then half will be smaller and half will be larger, so that we all get the same answer. What we do when we fall between two, I don't know how you want me to say this to you. I take the average of the two you fall between, or if you think about it, what I'm going to do is go dead in the middle. So if I take the average of the two, right? So this has two interpretations. That's the average of the two you fell between, the 10th and the 11th one, 22.5. Or if you think about it, 22.5, I just went right dead in the middle of 20 and 20. It's the same freaking thing. Now, let me ask you this. Does this seem right? 22.5. How many are less than 22.5? There are 10. How many are bigger than 22.5? There are 10. It does what we said it does. All right? Are we okay with calculating the mean and the median? Okay. Comparing the mean, X bar, and the median, M. Now, what we already know is this. X bar is not a resistant. Yes, I'm writing that same line down again just to get it stuck in your head. Is not a resistant measure of the center. Remember, it's influenced by extreme observations, the skewness or outliers. What do you think about the median? I'm going to back up here one more time to this problem, and then I'll come right back here. If that 60 had been 600, what was the median? It didn't change, right? It's still the same. It's still 20, right? Yep. Back here, I had noted that there was a possible outlier at 85. Suppose that 85 had been 175. Would that change my median? No, you see those numbers are placeholders. So one comparison of the mean and the median is this guy here gets all screwed up by extreme observations, and the median is the opposite of that. It's a resistant measure of the center. Everybody good with that? So, I got my hands here. The mean's here, and the median is here. The mean is used to measure the center when you see something roughly symmetric and no outliers. The median is used to measure the center when you have something that is skewed right or left and or outlier. Right? These two ends never come together. The mean stays over here, the median stays over here. Okay? Now, I would also like to talk about the relationship between the mean and median, depending on what the shape of your distribution looks like. So, what I'm thinking is the shape of the distribution. Now, we have three. Suppose I look at roughly symmetric. I'm going to draw you what I expect to see when I see roughly symmetric. I expect to see this look like that, right? That's about as nice and roughly symmetric it is. Where's the median at here? Where's that 50-50 point? Yep. Where would you expect the mean to be in something that's roughly symmetric? Now, I'm not going to draw them like they're the same, but I would expect the mean to be very close. In other words, if I'm looking at something roughly symmetric, right, no outliers here, then I would expect the mean and the median to be close together, not very far apart. And I'd expect them both to be very, very close together and to be in the middle of the picture, right? So, in words, X bar and M are close together. I don't expect them to be exact unless you let me pick the data and everything is perfectly symmetric, but I do expect them to be close together, close to the same value. Now, what's my other favorite pictures? And I'm going to draw them both for you. The book just gives them to you, okay, so when it's skewed, but I'm going to do this. Suppose we're skewed right. So what's my picture look like? Well, skewed to the right means I have this tail going out here, right? Yeah, that's skewed to the right. Now, where do we expect the median to be? Where do we expect that 50-50 point, that half smaller, half larger? I would expect my median to be somewhere like, what happens to the mean here? I don't know. Remember, it's influenced by those extreme observations going out the tail. I would expect the mean to be, in other words, when I see something skewed to the right, what I'm expecting is this. And I don't mean a little bit, I mean a good bit. Right? I'm expecting the mean to be larger than the median because the mean is pulled farther out the tail. What do you think skewed to the left is? Well, it should be the opposite. If I'm skewed left, okay, what's my histogram? What am I expecting to see here? I'm expecting to see the tail going out to the left. Where do I expect the mean to be? I'm assuming the median's right there somewhere, and then what happens to the mean? It gets pulled further out the tail. So what am I expecting in terms of symbols? I'm expecting, and students always want to know, so how are you going to test me about this? So I'm on page 51, and in the middle of the page there are some apply your knowledge problems. And I would like to look at problem 2.4 just to get you a feel for, okay, so how does somebody talk about one of these problems with you about here? 2.4, page 51, it says, the mean and median sales price for new homes sold in the United States in February 2016 were, one of the numbers is 301,400, and the other number is 348,000. 900,000. Right? Now, I mean, I don't know which is which, but they're going to ask me this. Respectively, which of these numbers is the mean and which is the median? Explain how you know. We're looking at what? We're looking at home prices. Anybody remember the other night we were talking and I said something to you about home prices when I was giving you variables we could measure that I expect to have a particular shape? What do we expect the shape of home prices to be? Actually, I went far enough to do one of the homework problems out of chapter 1 with that. Remember the Naples? And I was on the water, and all of a sudden I was here and out there. What do we expect? I expect skewed right. Right? That's what I expect out of the home prices. So, if I'm expecting skewed to the right, which one of these numbers is the mean and which one is the median? What do we know about the relationship of the median and the mean? When you see a distribution that's skewed to the right, I would expect this to be my median, and I would expect this to be, okay, I'm right here on this picture. There's my home prices, right? I would expect the mean to be bigger than the median. I expect it to be pulled out. That's how I know. So this is a problem where you got to know two things. You got to know this little story here, what variable we're looking at and what shape are we expecting. Then you got to know, okay, based on that, what do I know? Well, the mean's bigger. That's how one of these questions works, right? How does somebody talk to you about, oh, these guys are related according to the shape of your distribution. There it is. That's the kind of problem. All right? Now, again, here sits the mean. There sits your median. Mean, roughly symmetric, no outliers. Median, skewed, and or outliers. Yep. So now what we need is this. Those are my two measures of the center. Now I need measures of the spread. Right? So, we're going to start with something called measuring spread, measuring variability, if you like. We're going to start with the quartiles. Notice that's plural. Now look, I'm not even going to mention anything to you about what we were doing in chapter 1 where you were giving me the smallest and the largest. Hell, for all we knew, those were outliers and didn't tell me anything, right? So we definitely need to do better than that, but that was all we had back there. All right? So, notice plural, there's two of them. There's something called the first quartile. That's denoted Q subscripted with a 1. And then there is the third quartile. And it's denoted Q subscripted with a 3. Now, here's the deal. The quartiles, the simplest I can make this is 25% of the data, or 25% of the observations, are smaller than the first quartile. Right? That's what makes it the first quartile, right? It marks out the first quarter of the data. And then 75% of the observations are smaller than the third quartile. Hey, how come no mention of the second quartile? Or did we already? And I gave it a different name. You know, all of a sudden this guy's coming up and he wants to talk about spread. He's going to talk about the first quartile and the third quartile. Well, shit, where's the other one that divides 50? Oh, that's the median. Yep. I got one more question for you. I'm giving you these little statements here. And that's the way things are defined about the first and third, right? The first is 25% or smaller. The third is 75% or smaller. Well, look, if the first quartile is 25% smaller, what percentage is larger than the first? It's everybody that's left over, right? It's 75. If the third quartile's got 75% smaller, what percentage is larger? It is 25. Just like the median has 50-50, I can think about the other parts here too, but this is the way they're defined. All right? Now, one last thought. Q1 and Q3. Okay? Mark out the middle half. Let me ask you this. So here's my number line, right? Here sits the first, 25 here, 75 here. Here's the third, 75 here, 25 here. What percentage is between the two? 50. Right? That's why I mean it works out the middle half, right? So the first and the third quartile, what they do is those two values, I know there's 50% between there, so it's marking out the middle 50%. All right? So here's the other thing I promise you. If you can find the median in the set of the data, you can find the quartile. All right? So there's a box here on page 52. And they're going to talk about Q1 and Q3. And again, I'm not going to read everything and look at everything here because we're going to actually do it. And here's my thought. It says to calculate the quartile, number one, arrange the observations in increasing order and locate the median. So the first step on your way of finding the quartiles is put them in order, find your median, and then we will go from there depending on what you're looking at here. Is that okay? So, I want to look at this example 2.4. I'm back to my 15 North Carolina workers. We need to put them in order, so I'm going to put them in order for you again. Them being in order looks like this. Yeah, I actually had to write them smaller this time so I can get them all in one line. Me and you already found the median, right? Remember, this was my... Right? We did that earlier. Now, if we're going to find the first quarter, what I would like to do is if I could put my hand over this and mark and cover up everything to the right, I would. That's what I'm doing here, right? I'm only going to look at this part here. The first half. Let me ask you this. If I'm looking at the first half, and if I can find the median of the first half, what did I really find? I found the first quartile, right? Because if there's 50% here and I find the middle of it, there's 25 there. So, all those 7 I have underlined in blue there, how do I find the middle of those? How do we find the middle of any number of observations? You always take the number of observations and you add 1. You're going to divide by 2, and you're going to get 4. 4 is not the value, 4 is the location. So we count across. 1, 2, 3, 4, 1, 2, 3, 4. I just found the middle of the first half. I found the first quartile. And this has the same units as the original observation. Everybody okay with that? If you can find medians, you can find quartiles. Now, how are we going to find the third? What other colors do I have going on here? We're going to look at those 7. Do I have to do the 7 plus 1 divided by 2 again for you? No. Where are we going to start counting on my 4? We do not start counting the median. We start counting the 1 over. I'm going to count 1, 2, 3, 4. Notice, when I was looking at what was the first half and what was the second half, the median, since it was actually one of the values, I ignored it. I looked at the first 7 and the second 7. When I started counting to find the fourth 1 and the second 7, I didn't count the median. It was like it wasn't there. I looked at those 7 and I counted over 4 to get the third quartile being 30. Are we okay with that thought? So what do we got here? I've got the first quartile being 10 minutes, the median being 20 minutes, the third quartile being 30 minutes. What's the first step? Anytime you want to find medians and quartiles, yeah, I'm going to preach that to you one more time. You better put the shit in order. See, here's the problem. When I give you one of these for like a test question, and I know I'm not going to give them to you in order, there's only like 10 or 12 of them, right? Now, you know when I figured out the answers, I gave you the answer where you didn't put them in order, right? Because you're so happy to see I just got to calculate the median or something. Shit, I'm happy. And you'll forget to put them in order. Always put them in order, right? Smallest to largest. Okay? Now, we got to do one other thing here. I got to do one more example, and then we're going to put all this median and quartiles together for us. All right? So this example 2.5. All right? We're going to go back to our 20 New York workers. And I'm going to apologize up front here for our textbook. Because when I worked with the 20 New York workers before, didn't I use the stem plot to find the median, right? We just counted the leaves and went on about our business. All of a sudden, the book has forgot that we did that. And they're going to write the shit in order and do all that hard work again, right? Let's just be safe and do it that way. So I'm going to write all these 20 travel times of these New York workers out in order from smallest to largest. And I'm going to have to write really small because that's just me. I have to quit talking so I don't screw it up. Sorry, I couldn't get them all on her. Now, if you remember, we fell there when we were looking at the median, right? We fell between the 10th and the 11th one, correct? Remember, we found the median to be 22.5 minutes. Remember, we took the average of the two we fell between. Everybody okay with that, right? Remember, when you have an even number, you're going to fall between two. That's just the way it works out. Now, what we're going to do, how are we going to find the first quartile? I don't have to worry about throwing out the median. Hell, it wasn't a piece of data anyway, so I'm going to look at the first 10. What am I going to do? I'm going to take 10, add 1. What do I get here? What does that mean? What's that 0.5 mean? It means you fall between the 5th and the 6th. So when I count across, 1, 2, 3, 4, right? That's the 5th is a 15, and the 6th one is a 15. What's the average of 15 and 15? No, I got to be thorough. Q1, you're going to take 15 plus 15 divided by 2. So that I do the same thing every time on you, because it's not necessarily going to be, when you're finding a quartile, when you fall between two of them, hell, they're the same value. It's just by the luck of the draw here. What about if I want to find the third quartile? Let's look at those 10. Do I have to do 10 plus 1 divided by 2 again? No. I'm still going to get 5.5. We're going to count over 5. 1, 2, 3, 4, 5. Right? So the third quartile is between there. We can pick any number we want, but we all want to do the same thing and get the same answer. So we're going to take the average of the two we fell between. $42.5. Everybody okay with this? Now, you need to be able to find median quartiles by hand. If it's a small set of data, I'll make you put them in order. If it's a larger set of data, I'll just put the shit in order for you. The hard part here is, all right, maybe I shouldn't say this out loud. I believe the hard part here is putting them in order. And then we just take the number, add 1, divide by 2, and see where you fall. If you fall on 1, good. Fall between 2, take the average. One more question. Could I have done this with the stem plot instead of writing them all out? In other words, with the stem plot, could I have looked at the first 10 and then counted to 5.5 and took the average? Then could I have started here on the second 10 and counted 5.5 and, yeah. I wrote it out for you. We could have used the stem plot. Now, on Tuesday, we're going to start with this thought here on Tuesday. I want to get you started with it. But there is a way to collect up everything that's in this hand over here. Medians and quartiles. You understand? I should write it. Quartiles are a resistant measure of spread variability. Do you understand why? Well, let's back up here for a second. You write that down and I'm going to come back to it, right? See, if that had been 185, did the third quartile change? Did the first change? And just for the sake of things, I know these are travel times. So suppose that 5 wasn't a 5, suppose it was like a negative 50. Would it change? No, see, it's resistant to the influences of skewness and or outliers, just like the median is, except, the fancy way to say it is the quartiles are a resistant measure of spread and slice variability, because that's what the hell they measure, right? So they're in this hand here with the median. They never come out of this hand. Remember, the mean's over here, the median's over here. We just stuck the quartiles in here to measure spread or variability, right? You don't take anything from here and put here. You never use the mean to measure the center and the quartiles to measure the spread. That's a no-no. This hand here, that hand there. Well, just to reinforce that with you, there's something called the 5-number summary. These 5 numbers always stay together, and they're always the same 5 numbers in the same order. They are the minimum, smallest, the first quartile, median, third quartile, and the maximum. So in other words, in this hand here is the 5-number summary. The median is your center. These guys here gives you the spread of the middle 50%. Hey, what the hell is these guys out here doing? Right? So the minimum and maximum, they're giving you the extremes, right? They're giving you the smallest and the largest you see. The median's telling you the center. The first and third quartile, they're giving you the spread of the variability of the middle 50%. And then the minimum and the maximum, they're giving you the extremes. See that right there? That is a numerical summary of center and spread. The median is the center. First and third quartile are giving you the spread of the middle 50%. The minimum and the maximum are giving you the extreme. When we come back on Tuesday, we're going to look at both of these for the New York workers and the North Carolina workers, and there's a graph that goes along with the 5-number summary. Be careful going in the house. Please do not forget my homework for Tuesday, and we will see you on Tuesday. Hey, Rob.
Hey, Mike.
Everything go good?
It looked like everything went fine today.
Did you hear me good the whole time?
Could hear you good and see you good.
Oh, well, that's nice. All right, so we'll see you on Tuesday. Everybody be careful.
Hey, Mike, before you get too far away, I got one other question for you.
Go ahead.
How many students do you have?
No, you're going to have to talk louder, man. Get closer to something.
How many students do you have registered to be in the classroom here?
18.
18. All right,
What have you been having?
we had after the first night we had a full room, and then the second night is half the class did come.
Yeah.
And we're averaging probably in the 12 to 13 range.
Yeah, so that's probably not far off because, I made that deal with them. If they miss class, they could do the thing, and I think some of them are doing that with us. And then again,
I was just thinking,
maybe they decided not to do anything. You can't never tell, but I looked before I came down, and there should be 18 with you there.
okay, I was just thinking about test day, and if you have it on a Tuesday where we have the room next to us free, then if I had room for everybody.
Yeah, because what you actually have 48 seats, right? And you're supposed to have 18, and there's 36 streamers supposedly, but they all won't go to you. We'll have to do that count, man, when we get closer. And after I ask them where they're going to go.
So it looks like you have 48 seats, 24 in here and 24 next door.
Yeah, so it may work out where we can do the same thing we did in the fall.
Okay.
Depending on how many people are actually there to take a test, right?
Right. And again, this is a little early, but I was just thinking ahead, trying to figure all that out.
Yeah, because I've been worried about my afternoon class, my 2:15 class. Both rooms are full, and I got 48. I don't even know if we have a room that'll take 48, do we? I mean, Sam Wilson will take 40-some.
Knowing Dia, she already has something worked out for you on that class.
Yeah. Well, we'll definitely work this out. We'll have to work it out like a week before the test because